Okay, so like I said, I'm Dr. Valerie Frazer. I'm a behavioral optometrist in Waunakee and Delafield, Wisconsin. That's near Madison and Milwaukee. And today we'll talk about autism spectrum disorders and vision. Let's see. So the reason why we should talk about vision, especially with kiddos that are on the spectrum, is that 85% of kids on the spectrum have some sort of deficiency in their visual system. And the statistic might surprise a lot of you. But once I get to explaining more on what I mean about vision, I think you'll understand how that number becomes so high. The first thing I want to talk about when I talk about vision is that vision is not the same as eyesight. Just like hearing is not the same as listening and being able to speak, eyesight and vision are related, but not the same thing. Let me explain what I mean by that in a little bit. So one of the things that I think about when I think about vision is that the vision tends to be kind of hidden disability. So 70 to 80% of the brain is dedicated or connects with the visual system. So it's a big part of the brain that is somehow tied to vision. In fact, vision tends to be one of our dominant senses. The other thing we're going to talk about today is how vision is both a sensory system and a motor system. So we often think about, again, vision as being the eyesight part, but there's actually a lot of motor things going on there. And what do I mean by motor? Well, your eyes are constantly moving, but they're also helping to direct your other body movements. The thing is that because we always get tied into that sensory, is that a lot of these motor, vision motor type processing things get overlooked. So a lot of people are told that they have good vision because they have 20/20 vision, but that's not the only part of the visual system. There's more going on than just that. So let's just start with what does it mean to have 20/20 vision? So when you look at an eye chart, 20/20 vision means that you can see a certain size letter at a certain distance. So the distance is 20 feet, and the size of the letter, the bottom is the bottom number. So you have 2200 at the top of the eye chart usually, and then as you go down, like that red line there designates 20/20. So that's the size of the angle basically, or the size of the letter that you can see at 20 feet away. So one thing about that test is that it involves very little eye movements. The other thing about that test is that it's done at distance. So it tells you one thing about vision, it tells you about your central eyesight, but it doesn't tell you about other things. For instance, it doesn't tell you about eye movement control. It doesn't tell you about your ability to sustain clear vision at distance and near, how comfortable your eyes are doing that. It doesn't tell you anything about your near vision at all, really, because it's usually a distance test. And it doesn't tell you about depth perception or your awareness of space and how far away you are from things. It doesn't tell you about how your peripheral vision is processing vision or if you have good peripheral vision. It doesn't tell you how well your visual system is directing your motor system. And it doesn't tell you how vision is integrating with other senses, such as your hearing and your auditory processing. And it also doesn't tell you how well you're processing that information in order to understand it and then remember it. Here's a good example. So in this picture, if you've seen it before, you'll know exactly what it is. But if you haven't seen it before, then you might think it looks like a bunch of ink blots or, well, you know, nothing. You can see the picture fine, but it probably doesn't give you a lot of meaning. Now, if I show you the edges and what that actually is, especially if you're from Wisconsin, you probably recognize that this is a cow. So when I go back to the other picture, you probably see a cow, and that's because your visual system has now given meaning to all these indescript ink blots, okay? So ultimately, vision is about deriving meaning for what we see and helping to guide our motor functions. So we're going to talk a little bit about these areas. Today we're going to talk about visual spatial awareness. We'll probably spend a lot of time on that because I think it's really important for understanding kids that are on the spectrum. We'll talk a very little bit about visual efficiency skills and a very little bit about the visual processing of information. Those two areas, if you want more information directly about those, I've got a few other webinars on my YouTube page, which if you just YouTube my name, Valerie Frazer, F-R-A-Z-E-R, you can see those there. And I go into more detail on those other two skill areas in other webinars, usually the ones on vision and learning. But for today, we're going to talk, like I said, a lot about the visual spatial awareness and what I mean by that. So, I was talking about the vision, that there's, the eyesight, and then there's the other things that the visual system does, especially the motor components of vision. And the reason for that is that there's actually two visual pathways. So that's really important to know, that one pathway is all geared toward detail and telling us what things are. That's the ventral pathway. That's the one we learn about at school, where the eyes, it enters the eyes, it goes through the optic nerve, and then goes to the back of the brain, the visual cortex, to kind of process the picture, okay? So that's what we're really measuring when we measure 20/20 vision. That's one aspect that we're measuring. Now, there's a separate system called the dorsal pathway. And the dorsal pathway gives us information about where. So where we are in space, where things are in relation to each other, and then where things are in relation to us. All right, so all that goes through a separate pathway. That pathway is going to be more at the brainstem area or lower levels of the brain, completely different pathway. The two need to meet up and work together, but that comes later in the process. So, like I said, that is sometimes called the focal pathway or ventral pathway is the what is it part. So it's primarily your central vision. It mostly is what we're conscious of, and it is very innate, which means like it doesn't have to be developed or worked on. It usually just happens. And that's what most eye exams are testing, is more of that focal ventral pathway. Now, this other pathway, it's called the ambient vision pathway, or the dorsal pathway, like I said before, is again about where am I and where is it. So it usually involves the entire visual field, but also a lot of your peripheral vision. It occurs very subconsciously, so we're not really aware of it on a conscious level. It's just like breathing. You don't really think about usually breathing until you bring awareness of it, but it's not something that you usually are spending a lot of energy thinking about. It's highly involved with integrating with other sensory information. So it integrates with auditory, the information we get from our ears, or sound, vestibular, which is like our inner balance, and then proprioceptive, which is the information we get from our joints about where we are in space. And it is learned. So it is more learned than the focal pathway that just kind of develops on its own. This pathway is also very sensitive to movement and change. So what I mean is, like, if something's moving in the visual system, the ambient visual system will that'll wake that up. It's not as in tune to things like letters, which don't do a lot of moving. And then it helps to guide our motor system. So I think of it like an invisible GPS telling us where to go, how far away things are from us, how to avoid them, where to reach when you go to reach for something. And this includes the eye movements as well. So ocular motor movements are the movements we make with our eyes, as well as, again, those fine and gross motor movements. And again, the important thing to remember about the ambient vision too is that it usually happens at a subconscious level. And that's important because if you have to spend a lot of energy thinking about how far away things are, then that takes a lot of time and a lot of energy. And so if you are going to pick up something, let's say, pick up a glass, and you have to look at your hand and look at the glass and then use your focal system, let's say, to try to figure out where that glass is, you're going to make a lot of adjustments, or you're going to knock the glass over if you don't really know where it is. So we really want that ambient visual system to be working well and efficiently so that we can just do the things, whether we're walking or reaching for a glass. So one thing I like to talk about when I talk about poor spatial awareness in this ambient visual system is about tunneling. So tunneling is when you're not really using the ambient visual system very well. You tunnel. So there can be tunneling from an idea of like how far away things are. So some people, let's say if you're really engrossed in a book or I got a good picture here, or a video game, and you're kind of completely oblivious of what's going around you, that's a form of tunneling. Same thing could be happening where if you are really looking far away and really tuned to what's going on, but not really in tune to what's going on in close environment to you. Another form of tunneling is, I like to call it tunneling in reverse, is let's say you're trying to track and follow something. Let's say there's something where you're tracking and following. Now, there's three things that potentially can happen. You might be able to track and follow something with your eyes really well, with very, very little head movement and good accuracy of eye movements. But what more often happens, or what I see, is that kids, especially on the spectrum, have more difficulty with that. And they'll do one of two things. Either they'll look and track and follow well with their eyes, but completely have to move their head. In other words, they can keep their eyes on the target, but they're totally moving their head to do it. Or they are not moving their head, but not really able to very accurately track and follow the moving object. So their head will be still, but their eyes aren't really looking or being able to track and follow things well. So those are kind of like two forms of tunneling. So if you think about the person who moves their head but keeps their eyes on it, it's kind of like looking through a paper towel tube, where if you're going to keep your eyes on the target, you have to kind of move your head in order to be able to maintain or your eyes on it. So they're not really using their peripheral vision to guide them, but they're looking and they're using their head movement to keep their spotlight of attention on the moving object. The reverse, let's say a kid who keeps their head still, but can't keep their eyes focused on the central target, is using their peripheral vision, but not really engaging that central system in order to maintain their eye movements on it. So they might be really aware of the peripheral, but not able to maintain that midline attention or focal attention that they need to. Those kids are usually going to get a lot more distracted by things in their peripheral vision and have a lot more difficulty at maintaining good attention on close or near work, is generally what I find. Other forms of tunneling, sometimes you can see it in posture where you get really close to things, or maybe turning your head. So not being able to get that midline, if you turn your head to look or do some peripheral looking, that's a form of tunneling. You're also not using both eyes together when you do that, which is something that can happen when you have a ambient vision disorder. And sometimes it's just getting overwhelmed when there's too much in your visual environment. So for instance, going into a grocery store where there's a lot going on can be cause them either to ramp up their behavior and have a lot of more impulsive behaviors or anxiety, or cause them to withdraw and avoid those environments, or maybe even feel sick because those environments sometimes make people not feel very well. Those are all because that ambient visual system is not processing things in the periphery very well. So some of the things that the ambient visual system can affect is eye-hand coordination, catching a ball, handwriting. The visual system is going to guide the motor system and knowing where to go. Balance and posture, awareness of surroundings, or ability to process what's going on in their surroundings without creating anxiety or shutting the system down. Also has very strong connections to, like I said, the vestibular system and some proprioceptive system, auditory, and also the hypothalamus, which for those of you that don't know, the hypothalamus involves a lot of regulation, especially like regulation of sleep and wake cycles and just overall like homeostasis. So one of the things that we talk about when we talk about kids who are on the spectrum is sometimes they get into this fight or flight mode where they're either where they have get overwhelmed by their visual system and either withdraw or get ready to, like you say, like fight or get more aggressive or sometimes more impulsive in their actions. So other behaviors that are kind of related to this that we see, especially with kids on the spectrum, are they might be attracted to spinning or moving objects. They might be trying to wake up that ambient visual system, and so they like the spinning or the repetitive motion that comes from looking at those. Other thing you can see sometimes is hand flapping or putting their hands in front of their eyes. Again, it's a movement. That movement can give them a little bit more information about wake that ambient visual system up and tell them a little bit more about where they are in space. They may get overstimulated, like I said, in visually stimulating environments or unfamiliar environments. For some, being in a really big space can make them feel lost and not sure where they are. And then they'll often prefer dim lighting or become overstimulated in bright environments. Peripheral looking, like I said, that's kind of looking out of the sides of their eyes. That's related to the ambient visual system, but also not being able to use both eyes together very well. And then having difficulties with crossing the midline, which is being able to like pull your hand over and reach and grab something, your right hand maybe with something that's on the left is one example of crossing the midline. Difficulty with sustaining visual attention or withdrawing or ignoring a lot of things in their visual system. And then poor motor skills, so they might appear clumsy, poor awareness of space, and then poor sensory integration are all related to these deficiencies in the ambient visual system. Now, how this relates back to those visual efficiency skills is that the ambient visual system directs eye movements. So when you talk about eye movements, one, we're talking about fixation, which is actually the lack of eye movements, but the ability to just look and attend visually. Tracking, again, that's the ability to track and follow the eyes. We talked about that a little bit earlier. Focusing, that's the ability to maintain clear vision at near, but also be able to like switch their focus from near to far. In school, that becomes an issue, especially when you're copying something from the board to your desk. But also the ability to, if you sustain and efficiently sustain that clear vision at near, the eyes are getting fatigued, you're going to see a loss of attention. And eye teaming, which is the ability to coordinate both eyes together. So those are all, like I said, I go over in some of my other webinars on visual learning. And those are called visual efficiency skills. And those are some of the things I look at to see how the ambient visual system is working. The other thing about this is when all these other things are not working well, then usually it will also affect the development of visual processing skills. So visual processing skills include visual discrimination, being able to pick out details, visual figure ground, being able to find what's important in a crowded background, visual spatial relationships, understanding how things fit together, Visual form constancy, which is being able to understand that something's the same, even though it might be bigger or smaller or turned a different way. Visual memory, which is being able to remember what you see, and sequential memory, remembering things in a sequence. Visual span is being able to look at something and know how quickly you can remember and know what it is. Visual closure is the ability to be able to fill in the gaps when you're only given part of the information. Visual speed of processing is exactly what it sounds like, how fast you can process all of those things. And visual integration is how the visual system interacts with other systems, including motor and auditory. Again, I have another webinar that I go over these things in a little bit more detail. And that's where the vision can really impact some of the things that are in on school and learning as well. So when we look at how to treat these ambient vision dysfunctions, as a behavioral optometrist, sometimes called a neurooptometric optometrist, I look at three main areas to try to get the ambient vision system working more efficiently. One of the biggest tools I have in my toolbox is therapeutic lens prescribing, but we're also going to talk about these other two areas, syntonics and vision therapy. So therapeutic lenses. So these lenses, therapeutic lenses, are lenses that change our understanding of where things are in space. So we have the reality of where things are, and then we have where our visual system tells us things are. So if there's a mismatch there, sometimes we can use lenses to reduce the mismatch. So with these lenses, we're not looking necessarily at visual acuity, although they can sometimes improve visual acuity. But it's more about changing how the light enters the eye, usually with low power lenses or sometimes special prisms. So changing how light enters the eye, and by that, we're reducing the mismatch. Over time, that becomes their normal way of integrating. So that's why they're called therapeutic, because they're not compensating necessarily, but over time, the brain rewires around the correct orientation, and then hopefully that the patient will either reduce the amount of prisms that they need, or maybe not need them altogether. What's nice about these is that they do create an immediate change to the visual system. So you can oftentimes see an immediate improvement in how the patient is functioning with therapeutic lenses. One thing about therapeutic lenses is that not all optometrists are trained to learn how to prescribe these lenses, and very few, if any, ophthalmologists have any training in these areas as well. Typically, depending on the school that they went to, they might have a little bit of background in therapeutic lenses, but oftentimes it requires going to additional education sources to gain experience on how to prescribe these things. Syntonic phototherapy goes back to this idea of how the hypothalamus, or that regulatory center, can affect the visual system and behavior. So one thing that happens is when the patient goes into fight or flight, a lot of times that will increase that tunneling that's going on. So, but one of the things that we use is different light frequencies or colors to influence how that balance between what we call the sympathetic, which is the fight or flight system, or parasympathetic, which is kind of our system that helps with just regulating, keeping us on an even keel. So some other things that are often treated with light now, there's been a lot more research in this, and recent areas include, seasonal affective disorder, which is a type of depression where you don't get enough sunlight in the winter times usually, and it affects your mood. Depression, jet lag. There's a lot of research you might have heard about the effects of harmful blue light and screens on sleep and even behavior. And there's also a lot of more research going on about how light affects the health and mental well-being. And part of that is, again, going back to that hypothalamus, is that while we used to think there was only 2 photoreceptors in the eye, they called rods and cones. Now we know there's 3. Then the third one's called melanopsin. And that was found, maybe like 10 or 15 years ago. So it's really new to find out that there's actually 3 photoreceptors in the eye. So 2% of the fibers from the eye connect directly with this hypothalamus, and it's all about this regulation. So those, that melanopsin are really sensitive to light and the color of the light. So that's how different lights might be able to help calm down the chronic fight or flight response, reduce the visual tunneling, and then improve that ambient visual function that's going on. Here's an example of one of our home units that we use for SYNTONIC phototherapy. It's kind of a greenish light that we're showing off here, but to kind of give you an idea, so sometimes if you go to the blue end of the spectrum, that's kind of the ones that we use more for brain injury, kind of calms the system down. Red, it'd be the opposite end of the spectrum. That's like, you think about red as kind of revving the system up, stimulating what we call the sympathetic nervous system. Blue tends to stimulate more the parasympathetic nervous system. And then thirdly, the other tool in the toolbox is vision therapy. And that's how teaching visual skills and integration of the motor system, as well as the processing. So a lot of vision therapy involves getting better spatial awareness, and then using that better spatial awareness to direct those eye movements, depth perception, and other skills, as well as, like I said, processing of visual information. So finally, when we talk about vision, again, when vision's working well, it leads. When it doesn't, it interferes. That was what one of my mentors, Dr. John Streff, would often say, and I think it holds true, especially when we're talking about the ambient visual system and how it leads those other motor systems. So that's all that I have today.